At the end of the day, on June 30, 2018, at the shipyard in Philadelphia, a ceremonial launching of the container ship Daniel K. Inouye took place. This vessel became the first in a series of 5 ultra-modern ships of the Aloha class built for the American shipping company Matson. These powerful giants are capable of carrying up to 3,220 20-foot transport containers. They have been proclaimed the largest commercial vessels ever created in the United States and became a point of pride for the Philadelphia shipyard that will be producing them. All of this would be an incredibly impressive achievement, except for the fact that on the other side of the Pacific Ocean, shipyards such as Hanwha Ocean in South Korea are building ships 5 times larger. And while the American shipyard was able to produce only 2 vessels in the same time, its Korean competitors produced more than 50 next-generation mega carriers which now dominate global trade routes. And there is one more thing, the American shipyard is no longer American. Its new owner became the same South Korean company Hanwha Oceans, which they tried to compete with just a year earlier. In the race for leadership in global ocean trade, only 3 countries achieved a full and unconditional victory in one form or another. These are Japan, China, and South Korea. What's especially interesting is that from the standpoint of common logic, there are no objective reasons why these 3 countries should have ended up as the winners. If you ask an average person how these 3 countries managed to achieve dominant positions in modern shipbuilding, he will likely say something about cheap labor in countries like China. After all, ships are considered one of the simplest industrial products to manufacture. Therefore, it would make sense to build them where labor costs are lowest, right? But in this case, this factor has almost no significance. Labor costs make up only a small fraction of the total cost of building a ship. According to industry analysis conducted by the OECD, ultra-large container ships built at shipyards like Samsung Heavy Industries in South Korea typically sell for between $100 million and $200 million, depending on specific technical characteristics. Out of this final price, only about $10 million goes toward paying the workers assembling these vessels. Moreover, the majority of the work is performed using powerful automated equipment, and the technical specialists employed at these facilities are paid quite well, even by European and American standards. Real costs are almost entirely tied to the price of mechanical components, the volume of steel consumed, and the amount of time the vessel spends in the shipyard during construction. In many cases, such costs in China, Japan, and South Korea are actually higher than in other countries. Shipyards of these 3 leading countries won not because they were cheaper, they won because they were objectively better. Which leads us to an important question. If shipbuilding is such a critically important industry, why are other countries not even attempting to replicate the success of these 3? This story has 2 parts. The first is that the titans of shipbuilding in the past lost their dominant positions, and the second part explains how new Asian newcomers claim this strategically important industry. At the root of any success lies the ability to manage, whether it's shipbuilding or financial flows. When some lose control over processes, others create new models where transparency and awareness becomes a key advantage. Today, a similar shift is happening in investments. New tools are emerging that make capital management constant and accessible to everyone. At the end of the 19th century, absolute leadership in shipbuilding belonged to one country, Great Britain. The colonial empire of that time provided both the necessary resources and a powerful motivation to build the largest naval and merchant fleet the world had ever seen. Other European empires also gradually began expanding their capabilities as they too sought to secure their presence in the world's oceans, especially in the run-up to World War I. After the conflict was resolved, Great Britain and the other European powers continued to maintain dominant positions in shipbuilding. Trade and freight transport between Europe and North America were becoming increasingly profitable enterprises, which served as the key incentive for further growth of commercial shipbuilding. As for the naval forces, they remained in a state of mutual suspicion and rivalry throughout the entire interwar period. The grievances born from World War I had never been fully settled. Active preparations for a continuation of the confrontation were underway. At the same time, the countries attempted to agree on limiting the size of the largest ships in their fleets by signing the Washington and London naval treaties. These agreements established clear regulations regarding the maximum weight of warships, as well as quotas for their quantity for each side. There was hope that such measures would prevent a ruinous arms race. However, as we can easily conclude from today's standpoint, this strategy proved ineffective. One of the simplest loopholes in the treaties was the ability to build more smaller ships that were not subject to the imposed restrictions. But when World War II began, none of this mattered anymore. For the next 5 years, one single country would dominate global shipbuilding, the United States. Between 1941 and 1945, American industry built 6 times more ships than all other nations on the planet combined. US shipyards launched new vessels every single day. This armada was used to supply allies in Europe and conduct America's own large-scale operations in the Pacific Ocean. However, such incredible productivity created a specific problem, a colossal oversupply of vessels. Most of the ships built during the war were not impressive battleships or aircraft carriers, but supply ships whose task was to transport provisions across the oceans and support frontline operations. The American logistics system was so phenomenally powerful that the Pacific Theater even received specialized refrigerated ships that produced ice cream for troops fighting in tropical heat. According to legend, a Japanese general whose soldiers desperately needed food was stunned to discover that Americans had enough resources for such unprecedented luxury as ice cream ships. At that moment, he realized the war was essentially lost. One way or another, after the war ended, America's shipbuilding industry almost instantly came to a halt, even though from an economic standpoint this should not have happened. Maintaining a wartime-scale fleet was no longer necessary, of course, but this was exactly the period when international trade was entering a phase of rapid expansion. The Bretton Woods financial system pegged global currencies to the US dollar, which significantly simplified international settlements as all major governments voluntarily agreed to fix their exchange rates. Combined with post-war economic recovery, this created unprecedented opportunities for global trade. American shipping companies faced a choice. They could purchase one of the thousands of decommissioned Navy Liberty ships, or they could order a brand new vessel at a price dozens of times higher. Unsurprisingly, US shipyards did not have many customers. As a result, most of them simply shut down. But on the other side of the Pacific Ocean, events took an entirely different turn. To support its wartime efforts, Japan had been forced to develop advanced technologies, enabling the creation of some of the most sophisticated ships in the world. After the war, the American occupation actually stimulated the further development of Japanese shipbuilding. The United States sought to contain the spread of communism in Asia and viewed Japan as a strategic outpost for achieving this goal. By encouraging the growth of Japan's shipbuilding industry, the Americans not only gained a reliable trading partner, but also created numerous jobs for the local population, which in turn lowered the risk of radical ideas spreading, such as the seizure of means of production. Every time it seems smartphones have reached their limit, technology takes another step forward. We no longer look only at specs. What matters is how the device feels in real life, not just speed, but stability. Not just a camera, but a new way of seeing. That's what the new Xiaomi Mi 15T Pro has become, a flagship crafted with precision down to the smallest detail. The 3-camera Leica system covers a range from 15 to 230 mm, including an advanced Leica 5x telephoto periscope lens that delivers clean optical zoom and supports up to 20x hybrid zoom without losing quality. The main 50-megapixel Samilux camera with an f1.62 aperture produces rich colors and high detail even in low light conditions, and the Xiaomi AISP 2.0 system with a Portrait LM and Color LM modules automatically enhances photos while preserving a natural look. You don't even need a network signal to connect. Thanks to direct device-to-device communication, smartphones in this series can exchange voice messages at distances up to 1.9 kilometers without Wi-Fi or cellular service. The display is one of the brightest in Xiaomi's history, 6.83 inches, up to 3200 nits, with bezels just 1.5 mm thin. The refresh rate goes up to 144 Hz. Every movement feels smooth. At its core is the new MediaTek Dimensity 9400 Plus chipset, built on a 3nm process. The 5500 mAh battery supports 90 watts wired charging and 50 watts wireless charging. The body is made from a single piece of fiberglass, strong, solid, premium. Color options include black, grey and mocha gold. The Xiaomi 15T Pro is not just another update, it's an example of engineering turning into art. Learn more and be among the first by following the link in the description. In 1915, Japanese shipbuilding companies received a new form of support during the next military conflict, this time on the Korean Peninsula. UN forces, primarily American and European troops, were fighting against North Korean and Chinese forces. Japan's proximity to the front line made it the perfect base for repairs and maintenance. Instead of sending warships and supply ships halfway across the world for servicing, the military preferred to use nearby Japanese shipyards. The irony is that less than a decade earlier, these same shipyards were fighting against the very naval forces they were now repairing. But setting historical paradoxes aside, the investments from international forces became a catalyst for change, triggering the positive feedback loop in Japan's shipbuilding industry. It's notable that Japan, just like China and South Korea, suffers from a severe shortage of raw materials, especially iron ore, needed for steel production used in shipbuilding. As Japanese shipbuilders mastered the creation of massive container ships, they also helped push down global shipping rates. This made it easier to import the raw materials they needed from countries such as Australia and Brazil, further reducing the cost of building new ships. By the 1970s, Japan was producing more ships than all other countries in the world combined. European manufacturers at that time shifted toward cruise ship construction. The UK shut down the industry entirely, and the United States had essentially withdrawn from the race. At this point, it becomes clear that shipbuilding is closely tied to national military and strategic interests. The US recognized this as far back as 1920 by passing the Jones Act. This law requires that any ship traveling between American ports must be built in the United States, sail under the US flag, and be crewed by American citizens. The goal was to protect and stimulate domestic shipbuilding and maritime transport, ensuring the country maintained strong industrial capacity in case of war. Unfortunately, these ambitions failed to withstand real-world economics. American shipbuilders had guaranteed customers, the US Navy and local shipping companies like Matson, which removed any need to compete with global shipyards. This protectionism caused them to remain small, specialized, and far less efficient than the growing Asian conglomerates. But cost alone does not explain Japan's rise. Their true secret weapon was the financial system. By then, Japan had become the world's export leader, shipping everything from TVs to Toyota cars worldwide. But international partners paid for these exports mostly in their own national currencies. The US dollar might be the most powerful financial instrument in the world, but its direct purchasing power inside Japan was limited. Japanese export-oriented companies receiving payments in dollars were forced to convert them into yen to run their operations domestically. This created a major macroeconomic problem. Every time dollars were converted into yen, it pushed upward pressure on the Japanese currency. This dynamic did not correspond at all to the conditions of the Bretton Woods system, which Japan adopted in 1952 and which established a fixed exchange rate of 360 yen per 1 US dollar. Thus, to counteract the market activity of Japanese companies selling US dollars to buy Japanese yen, the Japanese government had to massively sell yen and buy dollars. These actions led to a paradoxical situation. Japan ended up with an excess of American currency. Instead of passively investing these dollars into bonds to receive interest income, the Japanese government developed a more strategic approach by creating a system of state-owned banks. One of them was the rather creatively named Export-Import Bank of Japan. Its key mission was to provide preferential loans to support the corporate growth of strategic export companies. How did this work in practice? Let's say that in the 1970s you were an international entrepreneur and wanted to create your own shipping empire. For that, you would need several ships. You have to start somewhere. At European shipyards, you would be asked to make full upfront payment in cash even before construction begins. If you didn't have enough of your own funds, you could go to a commercial bank, but it would require a substantial down payment and proof of your solvency, even if the project failed. However, when dealing with Japanese shipyards, you would be offered assistance from the state-owned Export-Import Bank. This bank used a portion of its dollar reserves, transferring them into the private bank of your choice. These funds acted as the initial down payment for the vessel, significantly lowering the entry barrier into the business. To make the deal even more attractive, the Export-Import Bank of Japan would also offer guarantees on the return of funds for ships built in their country. If you paid for a ship and the shipbuilder went bankrupt before delivering it, well, that would normally be your problem. Although the probability of a shipyard going bankrupt is statistically small, the transaction sizes are so large that most financial institutions require buyers to provide substantial reserve funds or government guarantees, exactly the type provided by Japan's Export-Import Bank. In 1999, the Export-Import Bank merged with the Overseas Economic Cooperation Fund, forming the Japan Bank for International Cooperation, JBIC. Despite organizational changes, its mission remained the same. According to its official website, it continues to provide advanced financing for shipbuilding projects, as well as financial support for satellite systems, port infrastructure, railway transport, and nuclear power plants.
In today's world, such state support has become an industry standard, drastically limiting the number of countries able to compete in the market of high-value exports. For a country to sell ships, it needs a state bank willing to provide insurance, and for a state bank to support the country, it must have massive foreign currency reserves. But such reserves can be accumulated only in one scenario. The country must already be a major exporter. If you add the requirement of access to the ocean, it becomes clear that the country must be not only politically stable, but also possess an advanced industrial base capable of building its own fleet. Today, only 3 countries meet all these criteria, and unsurprisingly, they are all located next to each other. However, this still doesn't fully answer the question. Germany, for example, formally meets all the same requirements, so why doesn't it have a massive shipbuilding industry? In reality, it does.
Moreover, Germany earns sums from shipbuilding comparable to those of South Korea. The difference is that the Germans focus not on the entire ship, but on its most expensive components. Companies like MTU and Caterpillar manufacture marine engines costing over $50 million each, which is nearly a quarter of the total cost of building a large vessel. A striking example is the German company MMG. The factory specializes in just one component, the production of ship propellers for ultra-large vessels. Every propeller installed on Asian-built ships eventually comes from Germany. Each propeller is based on roughly 110 tons of copper, aluminium, nickel and magnesium. These metals are melted into bronze capable of resisting salt water and enormous mechanical loads throughout the ship's lifespan. At current market prices, this set of raw materials costs around 1.2 million euros. But after engineers and precision machinery turn it into a finished propeller, the shipyards purchase it for more than 3 million euros. This is more than a 100% markup, even after accounting for labor and transportation costs. Now compare this with the shipyards themselves. Their production scale is enormous, but in essence they are simply shaping steel plates into massive boxes designed to carry other boxes. Financial data shows that about 80% of the cost of a container ship goes toward components. Another 10% is labor. This leaves only 10% for the shipyard to cover expenses and make a profit. Profitability is minimal, but this is both a weakness and a strength. Because for a nation to have its own shipbuilding industry, one more condition is necessary: political will. The government must genuinely want this industry to exist. Shipyards always try to increase profits, but the harsh economics of the business make it extremely difficult for new players to enter the market. Industry consolidation allowed these companies to form decade-long order books and produce dozens of ships of the same class. This dramatically reduced design costs and gave them a clear advantage through economies of scale. For everyone else, the logical choice was simply to buy from the big 3. Yes, owning a shipbuilding industry can be considered a strategic military asset, but Germany's example is instructive. Its navy is small and plays only a supporting role within NATO. They don't aim to project global power like the United States. Another point, even if, in a global conflict, access to Asian shipyards were cut off, the need for commercial container ships would still remain. They would have to be built somewhere.
In the US, strategic shipbuilding still exists, but realistically it has only one major customer, the Department of Defense, recently renamed the Department of War. A look at the Philadelphia shipyard slowly building small commercial ships under the Jones Act shows where the real money lies. One Gerald R. Ford-class aircraft carrier costs the US Navy about $13 billion. Despite being only slightly larger than a CMA CGM container ship, it costs 65 times more. Moreover, maintenance contracts for such ships are incredibly valuable. There is practically no competition. Obviously, the US Navy will never send an aircraft carrier to a Chinese dry dock for nuclear reactor repairs. Over the last 5 years, the largest container ships in the world have been built at shipyards in China, Japan and South Korea. Europe chose a different path. They still build ships, but in smaller quantities and with a focus on quality. They maintain their own naval forces and dominate the market for advanced high-tech vessels such as submarines. Parallel industries also thrive. Companies like Lursen, Abeking and Rasmussen, Benetti and Fedship, which build superyachts where price is secondary. For example, Jeff Bezos' midlife crisis yacht Koru, built by Ocean Co in the Netherlands, is only 127 meters long, less than half the size of new mega container ships, yet costs twice as much. This is because it's a high-tech, fully custom project designed for a client who doesn't care about the budget.
In terms of production volume, the three Asian shipbuilding hubs dominate the global market so heavily that all other players barely register in statistics. But the true value of this industry lies in its interconnected and highly interdependent nature.
Asian shipyards operate in the mass production segment, huge sales volumes with tiny margins, essentially the McDonald's of shipbuilding, a successful business model but with long-term limitations.